Okay, let's dive into this. Have you ever looked at a really tough exam question and just wondered, where do the marks actually come from? Well, today we are cracking the code. We're going to break down exactly how an examiner awards every single mark for a tricky GCSE maths question. And we're going to use their official guide to do it. So here it is. This is the question we're going to tackle. How in the world do you get full marks on this? It might look a little intimidating at first, but I promise, once you see the logic, it all clicks into place. And this is our secret weapon. This is the official mark scheme straight from the exam board. You can kind of think of this as our roadmap. It tells us exactly what an examiner is looking for, and we're going to follow it step by step to get every single one of those 3 marks. First things first, let's deconstruct this thing. Before we even jump into solving it, we gotta understand the different types of marks on offer and what we need to show the examiner to get them. So this question uses what are called P marks. The source material tells us a P mark is a, quote, process mark awarded for a correct process as part of a problem-solving question. And for this particular problem, there are 2 of these up for grabs.
All right, so how do we get that first process mark, that P1? Well, this is where it gets really interesting because there isn't just one right way to start this problem to get that first point.
You know, the mark scheme actually gives you some flexibility. It lays out 3 completely different but totally valid ways to get started. Let's take a look at all of them because understanding this is a huge part of your exam strategy.
So check this out. You've got options. You can start by finding the length of side AB or the length of side BC, or you could go straight for the area scale factor. Any of these will get you on the board with that first mark. Okay, let's walk through what's probably the most common way to start, finding the length of side AB. We know the triangles are similar, and the ratio of their sides is 3:2. So we just set up our calculation, 10.8 times 2/3, which gives us 7.2. And get this, that's it. Just by writing down that single calculation, you've locked in the first process mark. Even if you mess up the math later, you've already shown the examiner you know how to start the problem correctly. Okay, but what if you didn't think of that first? The mark scheme says you could find the area scale factor instead. Since area is a 2D measurement, you just square the length scale factor. So calculating 3/2 squared, or 2/3 squared, that's another perfectly valid first step for that P1 mark. All right, we've got the first mark in the bag, so let's see how we can build on that. The next step is all about forming a complete method to find the area of that trapezium. And that's what's going to unlock the second process mark. So what are they looking for here? Using the exact words from the source, this second P1 mark is for a complete process to find the area of the trapezium. This means you have to show all the logical steps that would get you to the final answer. And again, just like before, there's more than one way to do this. We'll focus on 2 main approaches. You can either use the classic formula for the area of a trapezium, or you could find the area of the big triangle and just subtract the area of the small one. So here's method 1, right from the mark scheme. And notice how it uses our first step. That 7.2 right there, that's the length of AB we just calculated. This formula shows a complete logical process to find the area. Or you could go a totally different route. With this method, you're calculating the area of the large triangle, and then you're just subtracting the area of the smaller one. It's a different way of thinking about it, but it gets you to the exact same place. And that is the absolute key takeaway here. The examiner doesn't care which correct method you use. As long as you show a full logical procedure, you will get that second process mark. We've got our 2 process marks. We're almost there. Now for the final piece of the puzzle, getting the right answer and snagging that all-important A1 mark, which is the accuracy mark. So, you've shown your starting process, you've laid out a complete and correct method, you've done all the calculations carefully, now you arrive at the final answer. Bam! 18.9. And here's the really brilliant part. All those different valid paths we just looked at, they all lead right here to this exact same number. So that A mark is an accuracy mark. The source tells us it's awarded after a correct method or process has been seen. So you can't just guess the number and get the mark. You absolutely have to earn it by showing correct working first. And here's another little tip, right from the source. The mark scheme explicitly says that they will accept trailing zeros. So if you wrote your answer as 18.90, that would also get you the full marks. Good to know. Okay, let's pull all of this together.
I think the most important thing we've learned here is that there are multiple valid ways to attack this problem and get full marks. It's not a one-size-fits-all situation.
Right, so you could find length AB and then go for the trapezium formula. Or you could find length AB and subtract the triangle areas. You could even start with the area scale factor from the get-go. All of these are perfectly valid roads that all lead to 18.9.
So when you see all these different valid paths laid out, it really makes you think, doesn't it? There isn't just one correct way to get the right answer. The real question is, which of these methods makes the most sense to you?